friends, welcome back to my channel Chemistry with DB. So in this video I am going to explain to you electrophilic substitution reaction of benzene, which is one of the most tested but also the most misunderstood topic in organic chemistry for A levels. So in this topic I am going to explain to you why electrophilic substitution for benzene and not electrophilic addition. Also, what is the general mechanism for any electrophilic substitution reaction, and then in particular I am explaining in this nitration of benzene. So first of all, let's see why electrophilic substitution and not electrophilic addition, just like alkenes. Now you know alkenes react by electrophilic addition reaction, in which what happens is when chlorine attacks the double bond, then in that case both atoms of chlorine join across the double bond and then there is no double bond left. However, in case of benzene ring, the pi system, which is an area of high electron density, it does attract electrophiles because it has got it's electron rich. However, the system is too strong or too stable and cannot be destroyed. So what happens is that the ring stays intact and one of the hydrogen attached to the carbon, that is substituted by the electrophile. So this is why electrophilic substitution reaction. Now let's see what's the general reaction mechanism for any electrophilic substitution reaction. So now in general, when the benzene ring is struck by the electrophile, then the electrophile substitutes one of the hydrogens here and the hydrogen leaves as H+, right? And this requires a halogen carrier or a catalyst. So the first step involves creation of the electrophile using the catalyst or a halogen carrier. Second step is electrophile attacks the benzene ring, and in the third step the halogen carrier or the catalyst is regenerated. Now let's look into the in-specific nitration of benzene. So the first step involves creation of the NO2 plus ion. Whenever nitrobenzene has to be created, then NO2 plus will be the electrophile here. So for this, the reagents needed would be concentrated nitric and concentrated sulfuric acid. Here, mind you, don't skip the words concentrated, because dilute nitric sulfuric acid will not have any reaction with benzene ring. It needs very strong electrophile, and that would require concentrated nitric and sulfuric acid. Another very important condition here is to mention is 55 degrees Celsius. In the second step, the electrophile, which is the nitronium ion, attacks the benzene ring, and in the third step what will happen is the sulfuric acid catalyst will be regenerated. Now let's see the curly arrow mechanism for this. Now in the reaction mechanism for nitration of benzene, in the first step, HNO3 and H2SO4 react. H2SO4 is a stronger acid. It donates a proton to HNO3. As a result, HNO3 becomes H2NO3 plus and HSO4 minus is created. H2NO3 plus breaks down immediately to form water and the nitronium ion, which is the electrophile here. Now in the second step, this nitronium ion or NO2 plus ion electrophile attacks the benzene ring. Here another mistake often that students do is they have the curly arrow going from NO2 to the benzene ring, which is absolutely wrong, because the curly arrow always goes from the negative to positive. Here is your electron ring pi system, which is negatively charged, so therefore the curly arrow would start from here and it would end up at the electrophile, which is the positive ion. Now as a result of this attack, what happens is the ring is temporarily disrupted. It becomes electron deficient as the ring uses some of the electrons to form a bond with NO2. However, this is just an intermediate and it's not a stable thing. So hydrogen gives the electrons to the ring so that the ring can reform. So the ring reforms with the NO2 still attached, and the hydrogen from here, it leaves without any electrons as H+. In the third step, this H plus helps to generate the catalyst, which was, so in the first step HSO4 minus had formed. So this H plus and HSO4 minus, they react and regenerate the catalyst. Okay, so the catalyst is regenerated. So I hope this mechanism is understood to you. Now there are, let's see as to why those two important conditions are needed. Firstly, the temperature of 55. So what's the relevance of 55 degree? At a temperature below 55 degree, the reaction would be too slow. So therefore you need to have 55. But at above 55 degree, what will happen? Multiple nitration could occur. So instead of getting a nitrobenzene, you could get dinitrobenzene or trinitrobenzene depending on the temperature. So therefore maintaining a reaction condition of 55 degrees is necessary if you are interested in nitrobenzene. Second reaction condition was concentrated sulfuric acid. Concentrated sulfuric acid acts as a catalyst here. It's used in the first step to generate the nitronium ion, and it's regenerated in the third step. So this is how it acts as a perfect catalyst here. I hope this reaction mechanism of electrophilic substitution you were able to understand. And if you like this video, then please like, share and subscribe, and because that would really motivate me to create more useful videos for you. So thanks for watching, and I look forward to see you on my next video. Bye. Take care.